You're looking at a single point of light. A point so bright it once fooled astronomers into thinking it was a nearby star. But it isn't nearby, and what it really is worse than you think. Imagine standing beneath a perfectly dark sky. Every city light gone, the Milky Way a bright river overhead. Now pick one faint star, barely visible at the edge of your vision, and learn it's not a star at all, but a monster half a universe away, outshining whole galaxies just to reach your eyes. Something that violent should not look that calm. This is the story of 3C273, the first quasar, the brightest persistent object ever seen in the distant universe, and a catalog of quiet horrors hiding inside one speck of light. By the time we reach number 1, you will never look at a star the same way again. I've spent months going through the papers and observatory logs. What follows is the real file on 3C273, stripped of comfort. Let's begin. Number 7. Number 7. The star that wasn't in 1963. Dutch astronomer Martin Schmidt, working at Caltech's Palomar Observatory, analyzed the spectrum of a radio source from the third Cambridge catalog, 3C273. The spectrum looked wrong. The familiar hydrogen lines were displaced, as if stretched. Schmidt realized the lines were redshifted by about 16%, meaning 3C273 is billions of light years away. Here's the scale. This star is so bright that, even from that distance, you can still glimpse it with a decent backyard telescope under dark skies. An object halfway across the observable universe, banging on your retina as if it lived in our own neighborhood. Cosmologically, that brightness is obscene. To shine that fiercely from that far, 3C273 must pour out more energy than entire galaxies. We had never seen anything like it. We still barely understand how to tame it on paper. We have never watched such an object up close. We have also never proved that we could survive doing so. Number 6. Number 6. A black hole that eats suns for breakfast. By the late 1990s, Hubble Space Telescope observations, led by teams including Martin Elvis and colleagues at the Harvard-Smithsonian Center for Astrophysics, measured the motion of gas near 3C273's core. From how fast that gas whips around, they inferred a central black hole of hundreds of millions of solar masses. Think of the Sun. 1 million Earths could fit inside it. Now multiply that Sun by several hundred million, crush that mass into a region smaller than our solar system, then feed it a steady stream of matter, forever falling, never hitting a surface. On cosmic scales, that turns 3C273 into a gravity furnace. Matter spirals inward, heated to hundreds of billions of degrees, blasting out radiation across the spectrum. The light you see is not from the black hole itself, but from reality being torn apart as it approaches the point of no return. We have never seen that point directly. We have also never ruled out that physics behaves differently there than any equation we trust. Number 5. Number 5. Brighter than a trillion suns. In 2012, observations with ESA's Integral Space Telescope and NASA's Fermi Gamma Ray Space Telescope measured 3C273's output from X-rays to gamma rays. Combined with optical data, astronomers estimate its luminosity at roughly a trillion times that of the Sun. Imagine every star in the Milky Way, all 100 to 400 billion, turned up to maximum and then multiplied several times over. That's the kind of sustained power this single point is hurling into the dark. At large scales, that kind of luminosity isn't just impressive, it's dangerous. Radiation from quasars like 3C273 can sterilize nearby galaxies, strip gas from space, and carve cavities in the cosmic web. We have not confirmed that 3C273 has erased worlds. We have also not confirmed that it hasn't been doing exactly that for billions of years. Number 4. Number 4. The jet that defies imagination. In 1966, Alan Sandage used the 200-inch Hale telescope at Palomar to photograph a strange, linear feature jutting from 3C273. Later Hubble images confirmed it, a relativistic jet, tens of thousands of light-years long, spearing through intergalactic space. On human scales, this is like a blowtorch that could reach from the Sun past the nearest stars, still focused, still lethal. Even light takes tens of thousands of years to traverse its length. Astrophysically, that jet is a puzzle. Magnetic fields somehow collimate plasma moving at a significant fraction of light speed, over mind-breaking distances, without falling apart. We have not yet built a computer model that reproduces every detail of that jet. We have also not found a law of physics that explicitly forbids it from pointing directly at us. Number 3. Flickering on human time in the early 2000s. Monitoring campaigns from observatories like the Fred Lawrence Whipple Observatory in Arizona showed that 3C273's brightness changes on timescales of days to hours. A galaxy-sized engine, twitching almost as quickly as a living thing. On Earth, we're used to big things changing slowly, continents drift, mountains erode. Here, a region larger than our entire solar system brightens and dims while you binge a series or sleep through the night. At cosmic scale, variability that fast means something important. The light is coming from a compact region. That ties the entire, incomprehensible power of 3C273 to a space you could cross, at light speed, in a matter of hours. We have not identified every process driving those flickers. We have also not ruled out that some are signs of physics we do not yet recognize. Number 2. Older than our solar system's story. Spectroscopic studies over decades, including work published by teams using the Very Large Telescope in Chile, show that 3C273's light has traveled to us for roughly 2.4 billion years. That means it began this particular outburst before complex life ever crawled onto land on Earth. Picture Earth when that light left. Oceans dominated, the sky likely tinged different colors, no forests, no animals, no eyes to see. Yet, across space, this quasar was already burning at almost full fury. Cosmically, 3C273 is a phase in a galaxy's life, a brief, violent youth, when its central black hole binges on gas and stars. But brief here still means tens to hundreds of millions of years. We have not watched a quasar like this switch fully off. We have also not guaranteed that our own galaxy will never look like this to some distant observer. Number 1. A beacon that warps our map of reality. In 1991, NASA's Compton Gamma Ray Observatory detected intense gamma rays from 3C273, confirming that it is a powerful beacon at the most energetic end of the spectrum. Today, missions like Gaia and Fermi quietly use quasars, including 3C273, as fixed reference points, the background grid against which we measure the universe. Here's the human comparison. It's like building your entire map of the Earth using lighthouses perched on erupting volcanoes. These are not calm benchmarks. They are catastrophes so distant they appear stable. On the largest scales, our definition of straight lines across the sky, our measurements of how the universe expands, even navigation of spacecraft in deep space, all depend on the assumption that objects like 3C273 are predictable beacons. Yet we know their engines are chaotic, relativistic, and only partly understood. We have not proved that our cosmic reference frame is perfectly stable. We have also not proved that the yardsticks we trust aren't slowly, violently changing under our feet. Most people will go their entire lives never knowing that our map of the universe is pinned to monsters like this. So what else about 3C273 is worse than we think? And what happens if our brightest beacons turn out to be unreliable? This is one chapter in a much larger story about extreme objects rewriting our cosmic atlas. The next episode goes deeper into how these engines may be shaping the fate of galaxies themselves. If you don't subscribe, you'll miss that investigation, and that's the one already keeping our researchers awake at night. Which of these 7 secrets unsettles you the most? Drop the number below, comma.